Okay, so now we're looking at a hexagon that goes around the circle, and we're going to keep it the same idea. The radius of the circle is 1. But you can see kind of right away that this is a little bit of a harder problem.
Yeah.
Because we're trying to figure out the perimeter of this hexagon.
Yeah.
But these aren't triangles.
But we don't know how long the sides are.
Yeah.
Okay, because we don't have triangles yet. Can you see a way to find a triangle inside of this hexagon?
Well, maybe we could connect these lines.
Okay, if we connected these lines, we're going to create a hexagon. You're absolutely right, but that's going to be the hexagon that's inside the triangle.
And then we go back to the other one.
And then we're back to where we were last time. But that is a very good idea. There's another line we might want to draw here to help us understand the bigger hexagon. Can you see a line that might be very helpful?
I don't really see it.
We got to draw something in here. So we got to connect some dots.
Well, if we lop off this part.
Well, that's going to be the next thing we do. Funny enough.
But what else?
What can we connect here that's going to help us understand the big hexagon on the outside of the circle?
Well, you could connect these dots.
Aha!
The corners?
Very good idea. Let's connect these
Corners.
to the center.
And then we make
Now we have what? What shape is this?
It looks like
That's an equilateral.
That's our friend, the old equilateral triangle.
Yeah.
And we don't know how long it is, but if we could figure out how long those sides were, then we could figure out the perimeter, right?
Yeah.
Now you notice it gets cut in half here.
Yeah.
So let's call this x. Let's call this x, so that our side length of the equilateral triangle is how long?
It's the equilateral. It's gonna be 2x.
2x, and that means this part here is 2x.
Yeah.
And now I have a right triangle. 1x and 2x. And is there some way we can solve for what x is?
The Pythagorean Theorem.
Aha! You ever heard of the Pythagorean Theorem?
Yeah.
Is the Pythagorean Theorem right? Is it correct?
Yeah.
Yeah, all right. So what does the Pythagorean Theorem say about this triangle? 1x
a squared plus b squared equals c squared.
So it's a squared plus b squared equals c squared. Well, a we could say is 1.
1 squared.
What's 1 squared?
1
Okay. What about x squared?
X squared.
is x.
X squared is just x squared. Now this can be a little tricky. What is 2x squared?
2x squared.
It's 4x squared.
Right, so we're going to say this is 2x squared, which is 4x squared. Boy, I hope that's on camera. Or 1 plus x squared equals 4x squared. Okay? You can move the x squared to the other side. I get 1 equals 3x squared.
And 3x squared.
What does this tell us? Maybe I'll let your brother answer.
Yeah.
This is a little harder, right?
Yeah.
You need probably. What do I need to do
well,
now?
X squared is a third.
1/3 equals x squared. So what is x?
X is the square root of 1/3.
X is 1 over the square root of 3. Now there's 2 plus or minus, right?
Yeah.
But we know this is a positive distance. Yeah, so we'll just take the positive.
Yeah, we'll take the plus.
And then we can also write this as by multiplying by the square root of 3 over the square root of 3.
Yeah.
This is the square root of 3 over 3. That's what x is. Okay, so Archimedes knew the Pythagorean Theorem. He probably walked over to Pythagoras' house and said, hey, can I borrow your theorem?
Or maybe Pythagoras invented the Pythagorean theorem before him.
Maybe that's true. Maybe that's what happened. So x is the square root of 3 over 3. That means 2x, this distance here, is 2 times the square root of 3 over 3. So the distance all the way around is 6 times that, right?
Yeah.
So where do I have room to write? So I get 12 times the square root of 3 over 3, and that simplifies to be what?
It's 4 times the square root of 3.
4 times the square root of 3. Now I have to divide by the diameter, which is 2. What's 4 times the square root of 3 divided by 2?
It's 2 times the square root of 3.
Okay, so we just got an approximation that says pi is approximately 2 times the square root of 3. Okay, now do you think this is too big? Is it longer around this way than the circle?
Well, yeah, I think it's longer because the circle you don't get these little bits here.
Right, it looks like it's longer. So in fact, and the other one was shorter, right?
So pi is a little bit greater than.
We have pi is 3 is less than pi, which is less than 2 times the square root of 3. So that's the very first thing Archimedes noticed. That you could figure out, you could put pi in between two numbers.
Cool.
And the next thing he did was really neat. So I got to draw one more picture, okay?
All right.
Okay.